Okay, we're going to go ahead and finish this up. Oops, this is video 9. Video 9. Thin film interference. Part 2. Okay. All right. I drew my drawings too big last time. Just wasn't thinking, got too into them, whatever. I drew them too big. So I made them a little smaller, picked them up, so now I have the room down underneath to make my final point about this topic, which to remind you is a lead up to thin film interference. We're not really there yet, but we have to cover this first. So what I said last video is that if you have a rope with a free end, and you send a wave down it, when it reflects, it will stay upright. There'll be no phase shift. If you fix the end of the rope, as in the case on the right here, if you fix the end of the rope and send a wave down it, when it returns, when it reflects, there will be a 180-degree phase shift, which we're just going to call a phase shift. 180 degrees is not important for us. Now, later on, we might say a little bit about it. But there's a phase shift. It gets inverted. It goes upside down. Okay? I'm a mess here. So what does this have to do with light? Well, suppose we have a boundary between two different media. N1 here, and we'll say that N1 is greater than N2. Okay? And let's say we send a wave towards it. Okay? Send a light wave towards it. Okay. When it reflects, as it will, right, according to the law of reflection, okay, the outgoing wave, the reflected ray, will have no phase shift. No phase shift. It'll be completely in step with the light coming in, right? In the same way that this wave that's reflected here with the free end is in step with the wave that came in. Comes in positive, goes out positive. There's no phase shift in the case N1 bigger than N2. So maybe this over here is glass, maybe this over here is air. Okay, maybe this is water, maybe this is air. Whatever. If N1 is bigger than N2, then when the light reflects and goes back, right, according to the law of reflection, here's the normal. When it gets bounced back, there's no phase shift. But in this case, if N1 is less than N2, so now we're going from, say, air to water or air to glass or water to glass, we're going from low index to high index. Turns out that when there's a reflection, okay, the reflected ray there is a phase shift. There's a 180-degree phase shift. So the light that gets reflected is inverted relative to the light that came in. Where there was a peak before, now there's a trough. Where there was a trough before, now there's a peak. Okay? In this case, where there was a peak before, there's still a peak. That part of the wave that was peaking when it was incident is the same part of the wave that has a peak when it's reflected. Peaks and troughs all stay lined up here. Here, there's a phase shift. Okay? If you go from a low index to a high. So when you look in a mirror, okay, and light reflects off the front of the mirror, right now as I'm talking to you, I can see a faint image of myself reflecting off the glass here. That light that reflects back at me is out of phase with the light that's going in. Okay? Where there were peaks before in the wave, there are now troughs. It doesn't change the way it looks to my eye. My eyes aren't sensitive to that sort of thing. Neither are yours, I hope. But the point I want to make is that when you go from a high to a low index, there is no phase shift. When you go from a low to a high index and there's a reflection, okay, the reflected ray is out of step with the incident ray. Okay, I'll say it one more time. When you go from a high to a low index, the reflected ray is in phase with the incident light. Okay. When you go from a low index to a high index, the reflected ray, the waves are out of step, perfectly out of step with the incident ray. And part of the problem here is that it's a little more difficult to draw, you know, the waves. But whenever you see a ray, think about waves. Okay, so that's the clip and save. It's all about reflection. You go from a high to a low, the reflected ray, no phase shift. You go from a low to a high, reflected ray, there is a phase shift. That's what you need to know. And we'll come back to this in another lecture or two, another video or two, once we get into actually, finally, thin film interference. That's the soap bubbles. See ya.